Hello, welcome to Grafana LGTM Stack course. My name is Mohammad, and I'm very happy to be here. In the previous section, if you probably remember, we talked about the architecture of Grafana Mimir, as well as setting up Mimir within our Kubernetes environment. We talked about the multi-tenancy, the power of multi-tenancy within Mimir. And finally, we integrated and connected Grafana to Grafana Mimir as a data source. So it looks good and everything is working well. But in this section, I'm just going to focus on getting metrics from different targets and writing these metrics remotely to Mimir. So to do that, you have different choices, such as Prometheus, Grafana Agent, or OpenMetrics. As you know, Prometheus is one of the most powerful tools for your monitoring solution to discover targets and writing those metrics into your, for example, Grafana Mimir instance. But in this course, I prefer to use Grafana Agent instead of Prometheus because I'm going to focus on Grafana stack. And Agent is one of the components of this amazing stack. So my choice for this course is Grafana Agent instead of Prometheus for writing metrics remotely to Grafana Mimir. Okay, so because of that, I go to the official documentation of Grafana Agent here. You can use Grafana Agent within your environment through different ways, and Agent is so flexible. If you take a look here, we have 3 different modes of Grafana Agent: static mode, Kubernetes operator, and flow mode. A static mode means that you can install Grafana Agent as a package within your, for example, Linux machine and try to configure your agent. And finally, agent will be responsible to get metrics from different targets and writing those metrics, for example, remotely to your Grafana Mimir or any different instances. Okay? And actually, systemd will be responsible to manage your package. For example, you can start, stop, upgrade, remove your Grafana agent package with your Linux package manager as well as systemd. So, whenever you want to export the metrics of any node, you can install Grafana Agent within that node and configure your agent. And after that, agent will be able to get metrics and writing them to an instance. Okay? But what about a static mode Kubernetes operator? If you're familiar with the concept of Kubernetes operator, it means that an operator is responsible for managing the life cycle of an application within a Kubernetes environment. And an operator includes a set of CRDs as well as a controller. For example, let's imagine that we install the operator of Prometheus within our Kubernetes environment. And after that, whenever you want to add or update your service monitors or alert rules and alert manager configurations and so on, you can do that through Prometheus CRDs. So you can change and apply, you can apply any new changes to the application that you have, for example, Prometheus. Okay, so you can do all of these works through an operator. So Grafana Agent has an operator here as well. It means that this operator will be responsible for managing the life cycle of Grafana Agent within your Kubernetes environment. And for example, whenever you want to get metrics from your Kubernetes pods, I recommend you to use static mode Kubernetes operator mode. Okay. So in this course, I'm going to use many different examples. For example, getting metrics from Kubernetes pods using static mode Kubernetes operator, and also getting metrics from our Linux node through static mode. Okay, so we have different examples to show you how they work. So first of all, let's start with static mode Kubernetes operator to get metrics of our Kubernetes pod. So I click on it and then I click on install the operator with Helm. So first of all, you need to add the repository of Grafana within your Kubernetes environment, updating your repositories, and then you need to install agent operator within a specific namespace, as you can see here. But for my case, Grafana agent is now available within my Kubernetes environment. So whenever I type kubectl get pod-n Grafana agent, you can see that Grafana agent operator is now available within my cluster, so I don't need to install this operator. But if this operator is not exist for you, you can install that through this link. Install the operator with help, okay? The next section is deploy operator resources. I click on it. To deploy operator resources within your Kubernetes environment, you have to follow a specific rule. And this rule is here. When you want to deploy resources, operator resources actually, the first type of resource, the first CRD that must be deployed within your environment is Grafana agent. This type of resource must be deployed first before any other type of resources here. It has the highest priority, okay? The second level and the second priority here is metric instance and log instance. Both of them are at the same level, at the same priority, okay? If you probably remember from the previous sections, especially in the section of Loki, we used a log instance to gather the logs of our applications within our Kubernetes environment, okay? But in this time, instead of log instance, I'm going to use metric instance to get metrics of our Kubernetes pods. Actually, log instance specify the instance of your logs. For example, you can specify a target for your logs, and it can be, for example, Loki. And metric instance is specifying a target or an instance for your metrics, and it can be Grafana Mimir here, okay? And the third level and the third priority here is for these three different resources: pod monitor, probe, and service monitor. All of them are at the same level, at the same priority, okay? In this example, for getting metrics of our Kubernetes pods, I need to use Grafana agent as well as metric instance and also service monitor. These are three different types of resources that I'm going to use for this example. Okay. So I scroll down here. Actually, you can see that the first resource that you must deploy within your Kubernetes environment is Grafana agent. But this resource has been deployed within my environment, so I don't need to deploy it once again because I used this Grafana agent resource for Loki section. So when I type kubectl get Grafana agent -n Grafana agent, you can see that this type of resource has been deployed within my environment. But if you are trying to experience these operator for the first time within your environment, you need to install and deploy this resource first before any other type of resources, okay? The second resource here is metric instance. Deploy a metric instance resource. Actually, I'm going to define the URL and the target of our metrics. And here, the target of our metrics is Grafana Mimir. Actually, we have a specific block here called remote write and a URL which specify the URL of our Mimir instance and basic authentication. We don't use basic authentication in this example, so I can remove these multiple lines here. So I copy the manifest of metric instance from here. And in this directory, I go to agent and I create a new directory here called metrics. And I go to this directory and I create a new file here called metric instance.yaml. And I paste those lines here. Okay. So let's scroll up here. The name is primary is good. The namespace is default. I prefer to use Grafana agent namespace instead of default here because I'm going to deploy all Grafana agent components and resources in Grafana agent namespace. So I change the namespace from default to Grafana agent. Very good. And the remote write here. If you probably remember from the previous section, when we deployed Grafana Mimir Helm chart within our environment, it deploys a specific component called Nginx, which is a reverse proxy to proxy requests to our Mimir cluster. Okay. So when I go back here and I type kubectl get svc-n Mimir, we have a service here called Mimir-Nginx. And this service is connected to a specific pod, and that pod, we're responsible to proxy requests to Mimir. So whenever you want to type the URL of your Mimir instance, you have to point to the service of your reverse proxy, and in this case is Nginx. So the name of the service is Mimir-Nginx, okay? So I copy this line, and I go to this file here. So we need to type the URL of Mimir Nginx service here. So I type http:// The name of the service is Mimir-Nginx. The name of the namespace is Mimir and /API v1 push. Okay. As I explained earlier, we don't need basic authentication in this example, so I remove these multiple lines from here. Very good. The next important thing is headers, and the name of the header is x-scope org-id equals to pods. As I explained in the previous section, I'm gonna show you how multi-tenancy work in Mimir. The target and the goal in this example is isolating metrics from each other. For example, I'm gonna get the metrics of Kubernetes pods, and I'm gonna say to Grafana agent that, hey, whenever you want to make HTTP post requests to Mimir, please specify a specific header. And this header is the name of the tenant. And the name of the tenant in this example is pods. It means that the samples, that the metrics will be stored in pods tenant within Mimir. Okay? So whenever you want to access to the metrics of your pods, you need to perform your queries against pods tenant. Okay, so you are specifying the tenant ID as a header within your Grafana agent configuration. In the next example, I'm gonna get metrics from our Linux node, and I'm gonna store the metrics of our Linux node within a different tenant ID, and that tenant ID will be nodes instead of pods. So the target here is isolating metrics from each other. Okay. So the name of the tenant here is pods, and it's good. So I save the file. Okay, let's go back to this page. The next resource here is Service Monitor. We have two components here called Kubelet and cAdvisor. The metrics of Kubelet and cAdvisor exposed by the Kubelet service. If you're familiar with the component, Kubelet component in Kubernetes, You should know that Kubelet is responsible to manage the life cycle of your pods and containers, okay? So whenever you want to have a good overview of your pods and their status, such as their metrics, you should get the metrics of Kubelet component and also cAdvisor. So the service monitor is responsible to scrape metrics from Kubelet and cAdvisor. The metrics of Kubelet exposes at /metrics, and the metrics of cAdvisor exposes at /metrics /cAdvisor. So here we have two different service monitors. The first service monitor here is related to Kubelet. It's looking for /metrics as a path to get the metrics of Kubelet. And the second service monitor here is related to cAdvisor, and the service monitor is looking for /metrics /cAdvisor to get the metrics of cAdvisor. Okay? So also we have a relabeling here, and it's relabeling the job to, for example, integrations, Kubernetes cAdvisor, and relabeling here to integrations, Kubernetes, Kubelet. Two different endpoints, Kubelet and cAdvisor. So we need to copy the first service monitor from here, and I create a file here called Kubelet service monitor.yaml, and I paste it here. So the only thing that I need to modify here is changing the namespace from default to Grafana agent. Okay? And I do the same for cAdvisor from here. cAdvisor.yaml. So I do the same here, changing the namespace to Grafana agent. Very good. So I need to apply these three new files from here. So three different resources created, two different service monitors for Kubelet and cAdvisor endpoints, as well as a metric instance which specify the target of our metrics. So in this case, the target of our metrics is Grafana Mimir. Okay? And then the most important thing here is multi-tenancy, and the metrics of our pods will be stored in a specific tenant, and the tenant here is pods. Okay, so when I type kubectl get pod-n Grafana agent, kubectl apply -f metric instance once again. So I think we have a problem here. The name of the namespace here is default. So, okay, we need to delete the previous metric instance because it has been deployed within default namespace. I want to change it to Grafana agent. Very good. And I apply it once again here. Metric instance. So when I type kubectl get pod once again, okay, the new resource has been deployed within Grafana agent namespace. So I type kubectl logs Grafana agent -0-n Grafana agent to ensure that everything is working well. Okay, so we need to go to Grafana instance to see our new metrics. So I go to Grafana dashboard here, and I'm gonna wait for 1 to 2 minutes to see the new metrics here, okay? As you can see here, the default data source is Mimir pods tenant. If you probably remember, we created two different data sources in the previous section, Mimir nodes tenant and Mimir pods tenant, okay? Let's go to data sources, and I click on Mimir pods-tenant, and you can see that we specified a header here. The key is xscope org ID, and the value here is pods. It means that this data source, Mimir pods-tenant, includes only the metrics of our Kubernetes pods. Okay, so let's go back to Explore. And for example, when I change data source to Mimir nodes-tenant, and when I click on select label, we have nothing here. It means that there is no samples and metrics within this data source, Mimir nodes-tenant. But when I click on Mimir pods-tenant, and when I click on select label, you can see many different labels here. It means that the metrics of our Kubernetes pods have been stored in pods-tenant, and this data source includes the metrics of pods-tenant. Okay, for example, I can click on a namespace, and these are all available namespaces within our Kubernetes environment. For example, when I click on Mimir, in the last 30 minutes, you can see the metrics of the containers and the pods within Mimir namespace. For example, their CPU usage, as well as memory cache, and so many different metrics here. Okay, so we successfully integrated static mode Kubernetes operator of Grafana agent with Grafana Mimir, and we successfully stored the metrics of Kubernetes pods into pods tenant, and this data source includes the metrics of pods tenant. Okay, so let's go for the next example. The next example will be installing Grafana agent static mode within our Linux node, within our Linux machine as a package, okay? And after that, we need to configure our Grafana agent to get the metrics of our Linux node, and those metrics will be stored in nodes tenant instead of pods tenant. And the metrics of nodes tenant will be stored in Mimir nodes tenant. Okay, so we are isolating metrics from each other. So let's go to do that. To install static mode of Grafana agent, you need to click on static mode here, and then set up static mode, and finally install static mode. You can install Grafana agent in a static mode in a Docker container on Kubernetes, Linux, macOS, Windows as a standalone binary. But for Kubernetes, I always prefer to use its Kubernetes operator instead of static mode. But for now, I'm going to install Grafana agent within my Linux machine. So I click on install Grafana agent in static mode on Linux. Okay. So you can choose one of them based on your environment. My operating system is now Ubuntu, so I need to execute these commands here. But if your operating system is Fedora or Red Hat, you can use these commands here as well. But for now, for Ubuntu, I need to copy these lines from here and paste them within my terminal. And finally, installing Grafana agent here. And also, as you can see here, Grafana agent is a systemd service. It means that you can manage this service through systemctl, stopping, enabling, disabling, and any other operating commands from here. And it means that you can manage this agent through systemctl. So if I type systemctl status Grafana agent, you can see that this service is now disabled. So we need to enable this service to use it. to scrape metrics from different targets. But before enabling this service, we need to configure Grafana agent. It's so important. So you need to configure Grafana agent before enabling this service. Okay. So the default path for the configuration of Grafana agent is etc Grafana agent.yaml. Okay. So I open this file and you can see that it defines a log level for the server, and the log level here is warn. For example, you can change it to any other log level you want. For example, if info, debug, error, and any other log level. And the script interval here, the default interval is 1 minute. You can also specify the write ahead log directory. Grafana agent is also able to scrape metrics from different targets you specify here under configs block. And also it's able to write metrics remotely to an instance such as Grafana Mimir. And one of the most important thing here is integrations block. It means that Grafana agent is able to be integrated with many different exporters, such as Node exporter, PostgreSQL exporter, MySQL, Memcached, Redis, web server, and so it means that it's able to be integrated with many different exporters. So when I go back to the documentation here, and when I click on configure static mode, we have an important option here called integrations config. And when I open this option here, we have many different exporter configs here. It means that you can use these exporter configs under integrations block. For example, one of these exporters is Node exporter, and it has been enabled here. And when I search for Node exporter here, yeah, you can see that the Node exporter config is now available within this option here. Okay. For example, if you're going to export the metrics of your database, for example, your database is Oracle or MongoDB or PostgreSQL, you can use their exporter config here, enabling that exporter under integrations block here. Okay. But for this example, I'm going to get the metrics of my Linux node. Because of that, I need to use Node exporter, and I need to enable this Node exporter, and it has been enabled already. As you can see here, enable true. And agent enable true, it means that you can get the metrics of Grafana agent itself using this option here. Okay. So my integrations is okay, but I don't need to get the metrics of agent itself. Because of that, I remove these two lines from here. But node exporter has been enabled. It's good because I'm going to get the metrics of my node. Write ahead log is val leap Grafana agent. The log level is warn. We can change it to, for example, info if you want, or any other log level. Script interval is 1 minute. We can change it as well. The write ahead log and the configs, I don't need to configs because I need to get the metrics from my node and write those metrics remotely to an instance, and that instance here is Grafana Mimir. So I don't need to use configs block here. So when I click on node exporter config here, you can see all available options of this configuration. For example, you can enable this node exporter here under integrations block, and these are all available options for node exporter. You can read the documentation of Grafana agent to check these features here. Okay, but for now, I just need to enable node exporter here. As you can see here, one of the important configurations here is remote write. So I don't need to use configs here. So I remove these multiple lines from here. Okay. And remote write is under global block. So I type these two lines. Very good. So the write ahead log and remote write, the URL scrape interval is 1 minute actually. And for remote write URL, we need to specify the URL of our Mimir instance. But for now, I'm going to access to Mimir from outside of Kubernetes cluster. Okay, because Grafana agent is now installed within my Linux node. So I need to access to Grafana Mimir from outside of Kubernetes cluster. So when I save the file and when I type kubectl get svc-n Mimir, you can see that Mimir-nginx is a service which its type is cluster IP. So if you want to access to this service from outside of Kubernetes cluster, one of its way is changing the cluster IP to node port to access to the service from outside of Kubernetes cluster, or using ingress. And its backend service will be Mimir-nginx. So you can use ingress or node port, but for temporary tests, I need to use kubectl port forward to expose this service. Okay, this is just for temporary tests. But for your options for production environment is node port or ingress, but the recommended way is using ingress for Mimir-nginx. So when I go to Visual Studio Code, I want to show you something for ingress. This is the regional Helm chart of Grafana Mimir. And when I search for ingress here, you can see that an option here is now available for ingress, and it's disabled by default. Enables equals to false. Okay, so if you want to enable ingress for Mimir, you can enable this block here and configure your ingress here as well. Okay, the backend service of this ingress will be this service, Mimir-nginx. You can configure it here. And if you're going to use HTTPS instead of HTTP, you can specify the secret name here as well as the host. And overall, you can enable and configure ingress within Mimir Helm chart, but it's disabled by default, okay? But for temporary tests, I can use kubectl port forward to expose this service, okay? So I open a new terminal from here and I type sudo su. And I type kubectl port forward svc/mimir-nginx-n Mimir. Port 80 and port 8080 are already allocated and they are already in use, but it means that I can't use these ports. So I can use, for example, 8090 to 80 from here. Okay. So now this service, Mimir-nginx, has been exposed through kubectl port forward. But for production environment, I recommend you to enable and configure ingress within Mimir Helm chart. Okay. So now I can access to our Mimir cluster through localhost, and the port is 8090. Okay. So I go back to the configuration of Grafana agent, API v1/push, and the URL is localhost, and the port is 8090. And the schema here is HTTP instead of HTTPS. And everything is good. It looks great. So let's enable. Okay. Another thing that is so important here is headers, because I'm gonna use multi-tenancy within Mimir, and I'm gonna store all metrics related to our node inside tenant ID of nodes. Okay. Because of that, I need to specify a header for Grafana agent to say to Grafana agent that, hey, whenever you want to make a post request to Grafana Mimir, please specify the header of tenant ID, and its tenant ID will be nodes. Okay, so I type headers, and the header here is x scope org ID. Okay, and it's nodes. Okay, so I save the file and I type systemctl enable -- now Grafana agent. So when I type systemctl status, you can see that this service has been enabled, that is now active and up and running. Okay. So I need to wait for 1 minute or 2 minutes to see new metrics within our Grafana instance. Okay. So I go back to our Grafana dashboard here, and I change the data source from Mimir pods tenant to nodes tenant, and I'm going to wait here. And yeah, these are all metrics available for nodes, and all these metrics are now stored on Mimir nodes tenant data source. Okay, for example, agent host name, address. If I click on agent host name, the host name is Ubuntu, for example. Okay, so you can see that we have an isolation between the metrics of my node, my Linux node, and also the metrics of my Kubernetes pods. Okay, the metrics of my node have been stored on Mimir nodes tenant, and the metrics of my Kubernetes pods have been stored within Mimir pods tenant. So we successfully isolated metrics from each other through the power of multi-tenancy within Grafana and Mimir. Okay. So, for example, if you are going to import a pre-ready dashboard for your metrics of your node, for example, you can search for node exporter dashboard here. And for example, we have a dashboard called node exporter full. And I scroll down here, copy ID to clipboard, very good. Let's go back to Grafana. I go to dashboards here and new import. You can also upload the JSON file as well as copying the URL or the ID of the dashboard here. Its ID is this, and I click on load. Its name is node exporter full. And the data source I'm going to use is Mimir nodes tenant, because this data source includes all metrics related to my Linux node. And I click on import. So I can use hostname here, for example, Mimir nodes tenant here. The data source. Whenever I click on Mimir pods tenant, you can see that there is nothing here. There is no metrics and samples in this data source, because all metrics related to my Linux node have been stored in Mimir nodes tenant. So when I click on it, we can see that the samples are now available here within this specific data source. Okay. The job name is integration/node exporter, and the host name is Ubuntu. This is the default port 1990, the default port of Grafana agent. If you want to see the default port of Grafana agent, and if you want to change or actually see the default port of Grafana agent, you can go to etc default Grafana agent. Okay. This is the HTTP address of Grafana agent as well as the gRPC address of agent. The HTTP address is 1990 and the gRPC address here is 1991. Okay. So you can change it if you want. But the default ports of Grafana agent is available within this configuration. etc default Grafana agent.yaml. Okay. So I successfully showed you how to work with Grafana agent, how to write metrics remotely from Grafana agent to Mimir through different ways, such as using Grafana agent Kubernetes operator or using and setting up static mode of Grafana agent within a Linux machine. And also, one of the most amazing features of Grafana Mimir is multi-tenancy, and we learned how to work with multi-tenancy. We successfully isolated metrics of pods and nodes using this amazing feature. And overall, thank you for watching. I hope you like it and see you soon in the next section.